For decades, countless UFO reports have surfaced from cities and countries around the globe. But not all UFO sightings have been reported from the surface of planet Earth. On July 19, 2009, viewers of a NASA video feed from the Space Shuttle Endeavour reported seeing a disc-shaped object hovering above the shuttle's mechanical arm. Space-based UFO sightings like this have purportedly happened throughout the history of manned spaceflight. Unspecified cosmic phenomenon? Or could it suggest the possibility that huge extraterrestrial starships are cruising the Milky Way galaxy?
Space travel between the stars, it's a staple of science fiction, right? You see it every night on television, you see it in the movies all the time. But could we really do it, or could any species really do it? Well, the distances between the stars are enormous, really enormous. Interstellar travel doesn't violate physics. It isn't that you can rule it out and say, there's absolutely no way they can come here. It's just that it's very, very hard.
Just traveling from the Earth to Alpha Centauri, our closest neighboring star at nearly 4.5 light years, is beyond the reach of our most powerful rockets.
If an advanced civilization were to visit us from a distant star system, we can pretty much rule out that they would use chemical rockets to get here. Despite the impressive pillar of fire and smoke that we see during Apollo, Saturn V, or shuttle launches, chemical rockets don't get you very far in the solar system.
To give you some context for that distance, our furthest known space probe is Voyager 1, launched in 1977. It's been flying for 34 years at 38,000 miles per hour, and it's only now starting to leave our solar system.
If its destination were Alpha Centauri, it would take over 56,000 years to reach even the closest star system. To engage in interstellar missions on timeframes of a human lifetime, around about 50 years, we can see that we need to increase the speed that we can travel by at least a factor of 1,000.
Scientists have determined that the speed of light is a mind-blowing 186,000 miles per second. A spacecraft traveling the star system would have to reach a significant percentage of that speed, even to reach the nearest star. The biggest obstacle is weight. A chemical rocket exacts a huge weight penalty because its entire fuel supply must be carried on board.
We can calculate that even to reach 6% of the speed of light using chemical rocket fuel, you would need more rocket fuel than exists mass in the universe. So we really know that it's actually impossible to reach another star system using chemical rocket fuel.
If extraterrestrial visitations are even possible, their spacecraft must solve this problem. In 2011, NASA's NanoSail D became the first solar sail to orbit the Earth. The ultra-thin 100-square-foot sail uses sunlight, or photon pressure, as a source of propulsion.
One of the immutable limitations of rocket propulsion is the fact that any rocket has to carry its fuel with it. A solar sail can take advantage of the naturally occurring resources, namely photons emanating from the sun, which can be used to propel that solar sail. Similarly, a hang glider can fly without any fuel or an engine just by taking advantage of the natural resources we're surrounded by, namely the atmosphere and the laws of aerodynamics.
To achieve sufficient speeds to tow a spacecraft supporting life forms, the sail would have to be huge, up to hundreds of miles in diameter. And because the photon pressure from a star would decrease the further the sail traveled, some have envisioned a concentrated laser beam directing energy at the sail.
Eventually, and sadly, this hang glider and all hang gliders at some point have to land. But a solar sail riding a beam of laser energy could conceivably travel to the stars.
The max speed of a solar sail? About 10% the speed of light. Travel from Earth to Alpha Centauri using laser-generated photons? About 45 years. Currently, NASA and other space agencies have plans for launching more solar sails. But there are other, more powerful sources of propulsion in the universe.